Hello everyone and welcome back to our course. In the previous lecture, we learned how to compare returns of our different stocks. And next up, we're going to learn how we can compare a different feature known as closing prices. Any other feature would do as well, actually. And we're going to learn how to create a heat map as well as a pair grid. All right, so let's create a new code cell and we will jump right in. Let's use Seaborn again to create a pair grid starting off. And the data we're passing in is going to be the same data frame we used in the previous lecture where we coded it out. Let's see. And that is going to be, yes, our stocks returns. And that is going to be here where we declare that stocks returns. It's our adjusted closing data frame. Okay, so we want to actually grab the data frame and pass it in as an argument for this pair grid. All right, and the result is going to be a figure of our returns. So we can create here a returns figure. Then we're going to take this pair grid and we're going to put it into a plot. So for that, we're going to use the help of another library known as Matplotlib. Let's import matplotlib.pyplot as pyplot. So pyplot is a sub-library of Matplotlib specifically for Python plotting. Pyplot is similar to Seaborn, but they do create different types of grids. So what I'm going to do is take the returns figure, my pair grid, and I'm going to use the function mapUpper. This is going to allow me to specify the types of plots that I want for the upper triangle. So here, if we look at this previous graph that we made, we can see that we have an upper right hand corner full of scatter plots. We have a diagonal full of histograms, and we have a lower right-hand corner, or lower left-hand corner, I should say, of scatter plots. And so we can actually specify what type we want the graphs to be. Let's start by specifying what type we want the upper right graphs to be. For that, we're going to use pyplot. We are going to use pyplot's scatter plot here. So that means the upper right-hand corner will have scatter plots. Then let's next map the diagonals with the function mapDiag. We're going to use pyplot.hist to create a histogram. We're also going to specify the number of bins to 30. That's the number of columns. And finally, let's map the lower right-hand corner. We'll grab our returns figure and we'll use the function mapLower. We're going to actually use a Seaborn type of plot known as the KDE plot. Now I'm going to run this code cell. And we're going to see our pair grid with specifically the types of plots that we wanted to show. So give it a minute to execute, and there we go. Look at this. Now we have here our new pair grid. At the top right-hand corner, we have a scatter plot. Here we're comparing every stock versus all of the other ones. So that's why we have here 16 different graphs. And you can see here, some of them are just the reverse of each other. For example, Facebook versus Amazon, and then there's Amazon versus Facebook. So at the top right, we have a scatter plot comparing the daily returns of different stocks. In the diagonal, we have a histogram, just because the diagonal is the stock versus itself. And then in the lower right-hand corner, we have a KDE plot. A KDE plot is also known as kernel destiny estimate, and it's visualizing the distribution of observations in our data set. It's very similar to a histogram. Here we're seeing the data using a continuous probability density curve. So this KDE plot is similar to a histogram, but it's less cluttered, and it's very useful, especially if you have multiple distributions. And like a histogram, the quality will depend on our selection of smoothing parameters. So here we can see the distribution, and the more densely colored the lines, the heavier the distribution. So this allows us to see similar to a histogram, but for the scatter plot, the density. So as you can see here, Amazon versus Facebook, and we have Facebook versus Amazon, right? So the two are different plots. One is a KDE, one is a scatter plot. With the KDE, we can actually see density more clearly, whereas with the scatter plot, we can still see density but less clearly. And as well, the scatter plot is showing us the density of actual data points, whereas for our KDE plot, we are seeing a continuous probability density. All right, next up, now that we have created our plot, let's actually calculate correlation. So I'm going to make another code cell here, and I specifically want the returns from all of them. So that is going to be in here, stocks returns. So I'm going to grab this stocks returns, and I'm going to get the correlation. So let's come back down to our code cell, and let's pop in those stocks returns. And we can actually use a function called core to get the correlations. So I can print out the results of this and run that code cell. And look at this. Now we have similar to our graph, but in numerical format. So we see the correlation of the returns for different stocks. Facebook versus Facebook, the correlation is obviously 1 because it's 1-to-1. Then we have Facebook versus Amazon, Facebook versus Netflix, Facebook versus Google, and we can see the correlation. All right, let's save this value stocks returns .core, and let's make what's known as a heat map out of that. So I'm going to create here a variable correlations and use the function core. Then I'm going to use Seaborn's heat map function to create a heat map. For the heat map, I have to pass in the data, which is my correlations. And I can also pass in FMT. We'll do 6G. You can set other values as well, optionally, like annotations, colors, and the shape of these squares. So now when I run this code cell, look at that. I get a heat map. On the y-axis, we have symbols, and on the x-axis, we also have symbols because we're comparing all of these stocks versus one another. On the right-hand side, we have this color scale going from 0 to actually 0.55, going from 0.55 at the bottom to 1.0 at the top. And those values are correlation. So if you have a beige color, that represents a 1-to-1 correlation. That's why we have a beige color on the diagonal. If you have an orange color, you have 0.9 correlation. We actually don't have orange anywhere. If you have 0.8, you have a red color, which means you have a high correlation. We can see Google versus Facebook, Alphabet stock versus Facebook stock. That is a red color, which means they have a high correlation. Then slightly less than that is purple, 0.7 correlation. We have a lot of purple. And the least correlation is 0.55, and that will be a black color. So still some correlation, but not as high as Alphabet stock versus Facebook stock. So as you can see, a heat map is a really great way of getting a fast visual. The reason being that we can quickly see with color how different features like stocks correlate to each other. Next up, we're going to learn how we can analyze risk with our stock data. So join me in our next section. We are going to learn how we can calculate risk in multiple ways.